Hello class, it's me, your professor, Prof. B. We are in our last full week of instruction, week 11. This is it. So all you have left to do is this final problem set number 5. Hopefully you should be okay with that between the tutorial video to follow along with the templates I gave you for the chi-square analysis. So content-wise, all that leaves us is the correlational / regression, simple linear regression set of analyses. And so these analyses are grouped mathematically. The computation, the y equals mx plus b formula is very similar, if not identical, for the correlation and simple linear regression when there's two variables. The difference you should know between the two specifically is a correlation analysis is simply testing whether or not there's a relationship, a mathematical relationship between two quantitative variables, okay? And usually those quantitative variables are continuously scaled, okay? They're not categorical. Hence, that's where the chi-square analysis comes into play. And the correlation analysis doesn't care which is an independent variable or a dependent variable. It just says, hey, we're just interested if there's a relationship between two variables. And the 2 points of information you need to know about the correlation, whenever you look at a correlation, okay, it's going to be on a scale of 0 to 1, okay, and that 0 to 1 scale refers to the strength or magnitude, okay, so the closer that number is to 1, the stronger the relationship. The closer it is to 0, the weaker the relationship. We say when it's around 0.5, 0.6 in the middle of that 0-1 scale, there's a moderate relationship. When it gets to like 0.7, 0.8, 0.9, we say there's a strong relationship. If it's 0.1, 0.2, we usually say there's a weak or little relationship. And then the second point with the correlation is the direction, whether or not it's positive or negative. And that's where that concept of the scatter plot comes into play, so you can see the relationship between those two variables. And a positive relationship is going to go up from the bottom up towards the right. A negative is going to go the other direction and go up and typically down on an XY axis. And one way to remember your X and Y axis, Y goes up and your X goes across. That's how I remember it. Now, the regression is the same thing as a correlation when there's two variables. However, now you're specifying which is an independent or a dependent variable, or an X variable and your Y variable. So X's are independent variables, Y's are dependent variables. X's are also called predictor variables, Y's are sometimes called criterion variables. We have so many words for the same thing in statistics. But basically you're specifying an order. So you could take the same exact correlation analysis and for two variables and say, well, no, actually, we think that this one of these variables is the X variable and the other one is the Y. Now you actually have the reason to do a regression analysis, in which you would then do an actual correlation analysis, and that's where we get that R value. Then we square it and get that coefficient of determination. That gives an estimate of the variation in the dependent variable caused by the predictor independent or X variable. But then it gives you that other additional ANOVA output where you look at the p-value. And again, depending what your decision rule is, 0.05, 0.01, you can make your decision on whether or not the relationship is not only statistically significant, but if that X variable actually does predict that Y variable. And that's it. It's pretty easy to do mathematically. In Excel, it's super easy to do, and I give you that little pointer in the video to specify that, type that little X in your Y in your column so you know. Well, that's it. If you have any questions, just ask. And wow, I can't believe we're here already. And I will have that final exam released by Wednesday, so look for it in your calendar in Leo. Let's have a great week.